Hello, this is Mingi, and we are going to discuss about MOSCAP Venn diagram today. We've got four situations. The first case, it says it is equilibrium status, which is not biased. This left thing is a N-type silicon, and this thing here is a P-type silicon. We're gonna assume that as a situation, and we gave a bias at a gate so that N-type silicon's energy band went up because there's a lot of electrons, and so the positive holes gather around here. So we call this situation as accumulation, and so we can see that the charge here seems to be positive and charge here seems to be negative. But when we give a semiconductor a reversed bias, the energy band goes down because it feels it's more positive than the actual state before. So the charge here seems to be positive, and charge here seems to be negative. Because of the density or concentration of the material itself, the depth of this charge here seems to be more deeper, and there's gonna be a lot of more electrons here because it seems to be plus biased here. And this last situation is also a negative, also a reverse bias, and it is much positive than the last situation, so the electrons here seems to gather around more than before. So the depth and an amount of the electrons here are relatively more, and here seems to be like positive charges, although it is both N-type here and P-type here. Although it is N-type here and P-type here, we gave a lot more voltage source on reverse bias, so it is different. It is reversed. So this is my this was my explanation about the MOSCAP Venn diagram. Thank you.